So, hello everyone, this is another problem on the kinetics of particles. We have a 50 kg block A is released from rest. That's very important. So it means that then V initial is 0 meters per second. Determine the velocity of the 15 kg block, this one, in 2 seconds. Okay, this is an important question. Okay, since all questions are new to you, so you may not know how to start the problem. Okay, so then step 1 is the first free body diagram. Okay, step 2 is that the unknowns versus equations. Okay, so it means that if the unknowns, okay, let me just, if we have the number of unknowns is equal to the number of equations, okay, then you can solve. Then solve. So if we have the number of unknowns more than the number of equations, so add the equation. So they say that case 1, case 2 till case 1. Okay, and then case 3 is that then if you have the number of equations, number of unknowns is less than number of equations, then delete some equation or check for the, so that's called, I mean, let's not go into deeper. Okay, this one's enough. Okay, so then these are the 3 cases that we will do today. Okay, firstly, let's start with the free body diagram. Okay, so we have one rope. Okay, then so there is one rope. Okay, that rope goes here to pulley E, and then from pulley E to pulley D, and then around the pulley C, and then comes back to pulley D. Okay, and then we have the B, and then we have the A. Okay, let's start first with the free body diagram. So then we start with the A, which is the simplest one. The A will have an weight, which is the, I'll just put it as weight, and then it has the tension of the cable. T is the tension of cable. So the cable keeps the the cable keeps the T, and then this one tries to go down, W. Okay, and then of course, as always, we will have the acceleration. So MA. So let me just put it this way. So MA and then A. Okay, then comes for the case B. Case B is a little bit different because you can see that case B is supported by this structure, but that one is supported by 3 structures. Okay, so let me just add it. So load B, so is attached to 3 cables, 3 cords actually. Okay, therefore best is to start from the pulley D. Okay, you can see that B is attached to that one, and that one is attached to 1, 2, and then 3 here. So let's do that. Then pulley D, we will have the pulley D. So it will have a tension in that way. That's 1. So we have a tension this way. That's 2. And we have a tension that way. That's 3. And those are balanced by some force here. I'll just call it as the force. So if, so then, and then since pulley D is fixed, okay, it can't move. So then it means that then F will be equal to 3 times T. And then since we solved the pulley D, now we can move to the load B. And then for the load B, it will have a weight downwards, which is very clear that it will have a weight. And then there will be a force, the same force, by Newton's third law. Newton's third law. Okay, because the force here, this one and that one, this will be, let's say that F, and that will be F. So Newton's third law. Okay. And then again we will have the acceleration downward, that will be ma of the b. Okay, these are the free body diagram. Now the time is to write the equations, which is step 2, and then look for the unknowns versus the number of equations, and then balance the number of equations and the number of unknowns. Let's do that. Let's start from the A. So for A, then, okay, let's first select the axis. Then axis, we will select the downwards is positive. Okay. Then A will be equal to then W minus T will be equal to M A and then the A. As always, as I told, the problem statement will correct the that problem solution actually will correct the direction of A. Okay, and then so W here is known because the A is 50 kg, so that will be 50 times 9.81. T value is unknown, and then M value is again 50, and then acceleration A is unknown. Okay, so I will not count the unknowns and given values. Let's finish first. And then the load B, we will have the 3T, the weight minus 3T will be M into A of the B. Then the weight of the B is 15 kg times 9.81, and then T value is unknown. This one is again 15. So summary. So what we have, 2 equations, and then we have 3 unknowns. So what are they? That is the T, and that is the A of A, and that's the A of B. Okay, and then so let me just add this note, that the note is the acceleration of A is not equal to acceleration of B, then since the weight is different. Okay, even the weight is the same, also the supporting chords are different. Supporting chords are different. Okay, that's the main issue here. But then we have 2 equations, we have 3 unknowns. Okay, so for example, if you multiply this one with 3 and then subtract it, then again you will be left with one equation and then three unknowns, again two unknowns. So I will pause it here and then continue in the next recording.